In functional programming, types can be very important, and there is a special syntax for type annotations borrowed from mathematics. For simple types, one can easily translate the C++ syntax. Instead of writing int x, we write x:int, which has the same meaning. X is an integer. A sequential container like this is written using square brackets. A pair like this becomes that. A good example for other class templates that need one or more types to be instantiated is the dictionary called map. In C++ we have this, which becomes that in our new notation. So far so trivial, but it gets really interesting when we talk about functions. Remember that functions are treated like normal data, so they are described in the same style. Foo is a function that takes a string and returns an int. In the last lecture we created two helpful basic functions, transform and keepIf. The declaration of transform, leaving out the template stuff, looks something like this. The type signature alone does not give away anything about the used functions, so let's write transform in our new style. The type declaration reads: the function transform takes two parameters. The first one is a function taking an a and returning a b. The second one is a sequence of elements of type a. Finally, transform returns a sequence of elements of type b. This is much more informative than our C++ function signature from above. Using std function we could also insert all this information like this. But we would be restricted to using std function. With our normal template variation, we can also use callable structs, global functions or lambdas without the need to convert them to an std function. So let's have a look at the type of keepIf. The process for reading this signature is the same as with transform. The function keepIf takes two parameters. The first one is a function taking an a and returning a bool. The second one is a sequence of elements of type a. Finally, keepIf returns a sequence of elements of type a. By the way, the types like a and b are type variables. In our syntax, the fixed types like bool and int start with an uppercase letter. The type variables start with a lowercase one. You can think of a type variable as a template parameter. In a concrete instantiation of this function template, the parameter would be replaced by the given argument. So keepIf used on a list of floats would become that. These type annotations of a function already tell us a lot about a function without the need to know its implementation. And they help us reasoning about how we can piece together different functions. Let's say we have a class lentil and a function is good1. We know immediately we can accomplish Cinderella's task of filtering them by simply using keepIf. There are not many different meaningful pure functions one could invent having the same type signature as keepIf, except perhaps for dropIf. This brings us to the next really big advantage. Sometimes you are looking for a function doing something specific, but you do not know its name. Functional Plus offers many useful functions, but even I cannot always remember all their names. But if you know the type signature you need, you can search the F+ API using this type. So perhaps you need a function that takes a sequence of sequences and returns them all flattened into one long sequence. You can simply go to this website and search for sequence of something to sequence of something, because the function you are looking for has to have this signature. You find out instantly that the name of the function you are looking for is concat. Or let's say you need a function that takes a sequence of strings to concatenate, but should put a special single string in between them. So the type would be vector of strings and string to string. Simply enter this into the API search. Even though it is using C++ notation for the sequence, it will parse it correctly. It also knows that a string is nothing but a sequence of characters, and thus will show you the function join, which is the generic version of what you are looking for. The fact that the order of parameters is swapped compared to our search query doesn't matter. The search engine takes care of this and finds our result nonetheless. So these kinds of types are an excellent form of documentation. You will find them used in other languages like F# and Haskell too. Here is a small exercise for you. Browse the Functional Plus API search website and have a look at some of the function types. See if you can translate back and forth in your head between the C++ type signature and the functional type annotation.